Good morning. Today we're going to talk about Unit 2, Lesson 4, Quadratic Functions. The general properties of the quadratic functions. The domain is all real numbers. That is, x such that x is an element are all real numbers. If one were to ask you for the domain, you could just say all reals. For any quadratic function, the domain is all real numbers. All real numbers. This is just mathematics notation here. The graph of a quadratic function is a parabola with a vertex or what we call a turning point. The graph will both increase and decrease. These are important properties of the quadratic function. These are properties of the graph of the quadratic. It's a vertex, has a turning point, and it both increases and decreases. And so there is a really nice IXL. The only new IXL is about graphs of quadratics. So they're going to look like that, or they're going to look like that. They're going to be up or down. And you know that we did that in Algebra 2. Okay, two forms of the quadratic function. Form number one is called the standard form, ax squared plus bx plus c. This is the standard form here. The vertex is negative b over 2a. F of negative b over 2a, and 0, 2 is the y-intercept. First thing you have to do if you're finding the vertex of a quadratic function that's given in standard form, you've got to pull out the a, the b's, and the c's. And we did that as well when we learned how to do the quadratic formula last year in Algebra 2, which most of you should have experienced the quadratic formula. The second form of the quadratic function is what we call the vertex form. F of x is equal to a times the quantity x minus h squared plus k. This is the vertex form. The vertex is actually this point hk. And this is going to be pretty handy if we have it in vertex form, because it makes graphing the quadratic really straightforward. The y-intercept is this ah squared plus k thing. We can investigate that down the road. All you would do is take this, and we're going to do this as well. We're going to take a vertex form and turn it into standard form here just in a little bit. But this is a very important form. The vertex form is important, and it is as important as the standard form of the quadratic function. Case number one, and there are two possible cases for this A, and I will point out that this A and this A, they're the exact same A. So they're the exact same A as what we call an arbitrary constant. It's a number within that equation, within that rule. The variables are X and Y. Those are the only variables. The A, B, and C are arbitrary constants. Whatever form we are, these A's are exactly the same. So do not be misled by that. There's two possible cases for A. A is either positive or A is negative. If A is 0, it's not. What happens if A is 0? Let me hold. Oh. Two cases for A. A is positive or negative. A cannot be 0. If A is 0, if A is equal to 0, then we're talking about linear functions. And this lesson is not about linear functions. So A cannot be 0 here. So this A cannot be 0. A does not equal 0. We're in the previous lesson. So case number one, if A is greater than 0. If A is greater than 0, the parabola opens up. And we say the graph is concave up. This graph here is concave up right here. This graph is concave up. It has a minimum point. Calculus. Concavity is a very important topic in calculus, so it's good that we know about concave up. This parabola opens up if A is greater than 0, and we say the graph is concave up. The range then, and this is what we have to determine on a quadratic, is the range. If it opens up, the range is going to be y greater than or equal to this k thing here. Well, this is the vertex. The vertex is HK. That's going to be the turning point, the minimum point if the graph opens up. So the vertex then is going to be y greater than or equal to that. And or y is going to be greater than or equal to f of negative b over 2a if we're talking about the standard form. Standard form range, vertex form range. And the vertex is a local minimum point. We're going to talk about local minimum points and local maximum points a lot in calculus. If a is less than 0, the parabola opens down. And we say the graph is concave down. If it is concave down, then the graph has a maximum point. And the range is going to be less than or equal to this k, or less than or equal to f of negative b over 2a. Standard form, vertex form of range. The x-intercepts, or zeros, of the standard form can be found by using the quadratic formula, which we discussed in Algebra 2. The other thing I will point out about this lesson, so this is the quadratic formula, what you did indeed discuss in Algebra 2. This is the discriminant of the quadratic formula because it discriminates, it tells us the nature of the graph. This is going to be very important as well. If I'm in standard form, these are the x-intercepts. The discriminant is b squared minus 4ac. And we know if this guy in here in the square root is greater than 0, then the quadratic has 2 real x-intercepts. If the discriminant is less than 0, the quadratic does not have any x-intercepts. And we say the roots are complex. This is where you're going to get complex numbers, those numbers with the i's. If the discriminant is 0, then the quadratic has 1 real x-intercept, which is the vertex of the graph. Enough talking! Shall we do an example? Let's, please. Let's find the x-intercepts of this particular graph. Okay, I find x-intercepts by letting the output equal to 0. So I do this. And I'm going to write the steps down, find the x-intercepts by letting y equal 0, or the outputs. So I'm simply going to solve this equation. 2x squared plus 4x minus 9. And I'm going to use the quadratic formula, so we get used to using the quadratic formula to find those x-intercepts. So before I use the quadratic formula, I'm going to pick out the a. The a is 2. The b is 4. And the c is negative 9. And we use the a, b, and c in the AC method of factoring a quadratic. But we're not going to factor this when we're going to use the quadratic formula. So therefore, the x-intercepts are going to be, using the quadratic formula up here, negative b, so it's going to be negative 4 plus or minus the square root of b squared, which is 16, minus 4 times a times c, all over 2a, so this is going to be over 4 as well. All right, so all we're going to do is simplify the discriminant. So this is going to be, x is going to be negative 4 plus or minus the square root, looking at our graphing utility, or a utility, so we don't make mistakes. Ooh. So if I simplify the discriminant, it's going to be 88 over 4. And I could simplify the square root of 88. So x is going to be negative 4. the square root of 88 off here to the side. The square root of 88 is going to be the square root of 4 times the square root of 22 plus or minus the square root of 4, the square root of 22 over 4, just simplifying it a little bit. So my x-intercepts are going to be negative 4 plus or minus 2 square root of 22 over 4. And you could take that one step further and put both of these guys over the 4. This is going to be negative 4 over 4 plus or minus 2 over 4 square root of 22. And I'm going to use my calculator. So if we take our calculator and we estimate these two numbers, these are going to be the two x-intercepts. And what I want to do then is graph this rascal here just for giggles. And we're going to give an estimation of this graph, f of x. And right away, we can see here are the x-intercepts, negative 3.3. Let's do 1, 2, 3, 4. 1, 2, 3, 4. So this x-intercept is going to be about negative 3, about right there. And this is going to be 1.3, which is about right there. So tell me, those are the x-intercepts. Does that graph open up or down? Anybody can read their notes and tell me? Why? And we have to make that statement. Since A is equal to 2 is greater than 0. So that thing is going to open up. Does anyone else remember the most important property of a parabola in XY land? Do you remember that property? Anybody? Okay, so what we see is that the parabolas are symmetric. So if they are symmetric, if they are symmetric, right smack in the middle of the x-intercepts will be this line of symmetry. And the line of symmetry is going to go through the x-coordinate of the vertex. So it has a minimum. And if I look about, I have this roughly about the same. And I have 1, 2, 3, 4. It's going to be about right. I think it's going to be somewhere about right in here. We don't know how low it's going to be. But I'm thinking that the vertex is about -1 something. Well, let's find the x-coordinate of the vertex. And the x-coordinate of the vertex is going to be negative b over 2a. And what is going to be negative b? Negative b is going to be negative 4, over 2a, which is 2 times 2. And it is indeed going to be -1. So the vertex is -1. If I wanted to find the output of that, I would simply find the function value at -1. And if I put f of -1 into the function, it's going to be 2 times -1 squared plus 4 times -1 minus 9. This is going to be 2 minus 4 minus 9. I believe that is 11. -11, -13 plus 2. So this point right here is -1, -11. And we know the graph is a parabola. And we're going to do a lot of sketching of parabolas. We need to be able to sketch parabolas. I wouldn't want you to be able to figure out those on your own. You would definitely have a calculator. Hey, and what is this y-intercept? What is this y-intercept? It's going to be this guy right here, which is 0, C, which is 0, -9. So that's an important point on that. And here's something else. Since the parabola is symmetric, if I'm at here at -1 and I go 1 to the right and I'm at -9, if I went 1 to the left, that value should be -9 as well, because that implores the property of symmetry of the parabola. On to the next page. Are there questions over this? Questions? Questions? Why would there be questions? I feel like you're not listening. I know some of you are. All right. So the next thing we're going to talk about is the average rates of change of a quadratic function. Sorry. Let's talk about the average rate of change of a quadratic function from x equals a to x equals b. The average rate of change is the slope of a secant line through 2 points, and I will give you a graphical representation of what this means. If f of x increases from x equals a to x equals b, so if I'm in a spot because a parabola will increase and it will decrease as we saw, if f of x increases from x equals a to x equals b, then this average rate of change is going to be greater than 0, and we say that on average f of x increases this number y units per a single x unit. We will have multiple examples over this, fear not. If f of x decreases from x equals a to x equals b, then the average rate of change is less than 0, and we say that on average, f of x decreases the absolute value of this negative number, y units per x units. So let's find the okay, so we're going to consider this guy right here. Okay. And the first thing we're going to do is find the other form of this quadratic. So we're going to go through this entire example, and I will tell you that there is an example like this. There's a problem like this on the assignment, and there is a problem like this on the free response test. So we're going to find the other form in this quadratic function. All we're going to do is simplify this rule. So the first thing we're going to do for simplifying this rule is we're going to take this x minus 1 and we're going to square that bad boy. X minus 1 squared is going to be x minus 1 times x minus 1, which is going to be x squared minus 2x plus 1. That's what this x squared minus 1 is. So this is going to be -3 plus 2 times this guy that I found here, x squared minus 2x plus 1. Okay, I have to multiply by 2 here. So this is going to be -3 plus 2x squared minus 4x plus 2. Make sure that I do my arithmetic correct, please. So the standard form of this will be 2x squared minus 4x minus 1, if I'm not mistaken. So this is the standard form, and this is the vertex form. And one thing that I can do with this vertex form is I can reach in and pull out the vertex. If I reach in and pull out the vertex, it's going to be 1, -3. So that's going to be the vertex. And where did I find that out? Here's my h and here is my k. HK if I look back at my notes. So the next thing, and I think I did the arithmetic correct. Did I do the arithmetic correct? All the arithmetic correct? Morgan, thank you. I want to determine if the function is concave up or concave down. Explain. We're going to do a lot of explaining calculus. We're going to do a lot of explaining in this class. So, is this function concave up or concave down? Why do you think? Stella, have any idea? If you go back a page, you will see your notes and figure it out. Concave up. Why? Bella, do you know? Concave up since this is concave up since A is equal to 2 and 2 is greater than 0. And that's the reason. You just can't say it's concave up since A is greater than 0. You have to tell me the specific A. You have to be specific. So this is concave up since A is equal to 2. The vertex of the graph, oh my goodness, I found it earlier. 1, -3. Sorry. And there again, if I did the negative b over 2a, which I didn't have to do because I have it in vertex form, but if I did the negative b over 2a, what is negative b over 2a? Well, negative b is going to be 4 over 2 times 2, and that is going to be 1, and that does correspond with that 1. And then if I put 1 into that, I can put 1 into that real quick. 2 minus 4 is -2, minus 1 is -3, and that would verify the vertex form again. The minimum point or maximum point, since it is concave up, it is a minimum point, and this guy right here is the minimum point. Find the range of this function. The range of this function is all y's such that therefore the range is, yes, a is positive, so y is going to be greater than or equal to -3, and that's going to be the range of that guy. Determine the nature of the x-intercepts if they are real and find them. So what we're going to do is we're going to look at the discriminant, and we're going to write that down. We're going to look at the discriminant. And the discriminant is b squared minus 4ac. B squared, and we're going to pick out the a, b, and the c's. And the a is going to be 2, the b is going to be -4, and the c is going to be -1. A, b, c. The discriminant is going to be b squared, which is -4 squared, minus 4 times a, which is 2, times -1, bam. That bad boy is going to be positive because it's going to be 16 plus 8, which is 24. So the x-intercepts simply are, now this is nice, and we did this in Algebra 2, it's nice finding the discriminant because it makes using the quadratic formula so easy. And now by the quadratic formula, then the x-intercepts are going to be, and I need not rewrite the quadratic formula, going to be negative b, I can. So looking at the quadratic formula here, we're on the next page, home skillet. So the x-intercepts are going to be negative b, which is going to be 4, plus or minus the square root of the discriminant, which is 24 over 2a, which is 4 as well. So the x-intercepts are going to be, and I can just write it this way, 4 plus the square root of 24 over 4, comma, 4 minus the square root of 24 over 4. And you can simplify those yourself. I want to get to the verbal description, the average rate of change. Tell me, where is this function increasing? Determine where the quadratic function is increasing. So f of x is increasing when x is, this thing opens up, correct? This thing opens up. It has a minimum at 1, -3. It's going to open up. So this thing is increasing when x is greater than, when x is greater than 1, because that's the x coordinate of the vertex. So if I do a little graph of this guy right here, -1, 3 is going to be the vertex. That's a horrible line. I'm going to get him out of there. -1, 3, or 1, -3. This is the vertex. And we know the y-intercept is going to be -1. So this guy is going to look like this. Symmetric. Where this guy here is 1, -3. Okay, and I'm going to find the average rate of change in f of x from 2 to 4. So I'm going from 2 to 4. So the average rate of change, the first thing I'm going to do is find this. F of 4 minus f of 2 over 4 minus 2. All right? So I have f of 4 is going to be, if I did the mathematics, f of 4 is 15. F of 2 is -1. So it's going to be f of 4 minus f of 2 divided by 2. This is going to be 15 plus 1 is 16. Divided by 2 is 8. And here is the verbal description that we've been waiting for. So our verbal description is, on average, notice this guy is positive. 8 is greater than 0. So we say, on average, f of x increases eight y units per x unit. On average, f of x increases 8 y units per x units, increases on average from, and we have to go the interval, from x equals 2 to x equals 4. And that's the verbal description that is on the assessment. This is extremely important for next year, that you learn how to do that. That is a long lesson.